Okay. So can you give like a brief 1 minute overview of like who you are, what you're interviewing for, years of experience, how much like algorithms you've done, stuff like that?
Sure. So I'm a engineer, software developer with 3.5 years of experience, mostly working on C and C++ code that interacts with cloud servers and create help create tools to manage like the hardware on cloud servers. And currently, I'm preparing for interviews. I would like to ramp up over the next like few months and be prepared for big tech interviews.
Okay. Yeah, that sounds good to me. Okay, so we can get started. So I'm gonna give you the first question, and then also, so you're not gonna be able to run your code, and we're gonna stop at 2:46. That's gonna be 40-minute interview, 2 questions, medium level, and then we'll do like a debrief after that. So the first question is you're given a root of a binary tree, and all these nodes have unique values. So all the nodes of the tree have unique values, and you're also given a start node. Yeah, and this will be in the form of an integer. So the root of the binary tree will be like a class, and then the start node will be in the form of an integer. And at minute 0, the start node is infected. And the infection spreads one node in all directions a minute. And I want you to tell me at what time the entire tree will be infected. So just to give an example, let's say our tree happens to be like this, and let's see, children 5 and 3, and 5 has a child 4, and then that has like 9 and 2, and then the 3, let's say, has a child of like 6. So if the start node is 3, then that means that our entire tree will be infected in 1, 2, 3, 4. So the answer will be 4 here. Start node. And you can feel free to ask me anything you need, or any clarifying questions or anything.
I see. Um, so if it starts at this node, in 1 minute, the virus would spread to node number 1 and node number 6. And then at 2 minutes, it would spread to 5. And then at 3 minutes, it would spread to 4. And then, am I understanding that correctly?
Yes.
Okay. I see. So I guess one difficulty in this problem is figuring out how to get from 3 upwards to its parent.
Mm-hmm.
So I think initially what I would want to do is figure out where the starting node is situated in the tree.
Okay.
So that I know where I can either go backwards from or go forwards from. So
Okay.
hypothetically, let's say I start on the head, I would go down to 3 and identify that this is the start point. And then I have 2 choices. I can go up gradually, and then eventually when I reach the head, I can start going down. Or the other option is I start at the virus start point and then go down the binary tree. So I sort of have to keep track of both directions. So that kind of makes me think that there could be a recursive approach where I have like I pass in a node to a function and it iterates downwards over through unvisited nodes, and essentially let's say I'm at this spot here, I could pass in the child nodes, and then I could also pass in the parent node to the recursive function and iterate my way down. And then I would do this in sort of a BFS sort of way where I keep track of the number of steps that I had to take to cover all the nodes. So that's sort of what I'm thinking of right now.
Okay, and so in order to do BFS, like you said, you can't go from 3 to 1, right, in a tree, because a tree only has children. So how would you fix that issue?
So while I iterate down to 3 to find like the starting point of the virus, I suppose I could keep track of the path that it took to get down, and then I would do I would keep track of the path that it took to get down to this, so I know which nodes are connected to this specific infected nodes.
Okay, but so maybe you do keep track of the path, but what if there's like other nodes that we need to visit or something, like this whole side, for example, right? This isn't even on that path. Like a 3 is on the right and this is all on the left. So how do we know how long all of this takes? Or there could be other cases where, you know, maybe 3 is like on the right side of the tree, but there's some other path on the right side of the tree that didn't get to 3, but then that path is like super long, you know, some stuff like that.
Yeah, I see. Yeah. Let me try creating some sort of stack. So let's say we start at the head. So we do iterate to 1. And I guess we do, if we look at their children, we would go to 5 and 3. So we do something like this. Now, let's say we identify that 3 is the starting point of the virus. So from that, we could start popping. Then we could like split the traversal into 2 parts. One part is continuing down this path from 3. So essentially you would, I guess you would sort of have 2 points that you're traversing from. One is you're traversing down from 3 to see how long it takes to cover everything that's in the subtree that starts at this 3 here. Mm-hmm. And then you would also iterate through the subtree that starts at this 1 here. But you would ignore anything that you've already visited, and you would have these 2 subtrees sort of going simultaneously, and you would just like keep track of what the total time is for both subtrees to complete.
So what I was saying is basically imagine, like, let's take another example. Let's say there is no left side, and there's only a right side. So maybe it's like 1, 2, or let's say there is a left side and it's just called X, which is that thing you were saying, right? That separate traversal. So let's say this is like some big thing that we're going to ignore for now. But let's say we have like this, you know, and then maybe we have like whatever, like 1, whatever, some stuff here. And then there could be other stuff like in other places, like maybe there's some stuff here. And now the infected node might be like here. I did say you can't have duplicate nodes, so, you know, let's just say something like this. The infected node is like here, and now you have to do like this infected node's path, plus also the path from like the 5 down to these nodes, plus like this path as well. You see what I'm saying? So like there's cases where you have a ton of these paths. It's not just 2. So basically I guess the problem we had was the reason this is hard is we can't traverse up, right?
Yeah.
So instead of trying to do the stack, which I don't think will work, or even if it does, it'll be very complicated because there could be a ton of paths. How can we solve that problem? And then like do you know a data structure we can use that would let us traverse up? And then from there, what can we do that would make this really easy?
I guess you could do like a hash map that stores a parent of every node. That will let you traverse up pretty easily.
Okay. So for every node, you'll store the parent as well, and then you can basically traverse down and up.
Yeah, because you would have like a pairing.
Okay. And then once you have that, then what algorithm can we use to get like the full thing?
So the parent is so let's say in this case, like let's say 4 is infected or 5 is infected nodes. So you iterate down to 5 somehow while keeping track of the parents of every node. Once you get to 5, then you start. Then I guess you would do BFS from 5 and you would check its children while also checking its parent. And then from the parent, then you have to iterate down again. So there is sort of a repeated subproblem where for every node, you need to, from every node starting from the infected node, you have to check its, operate on its children and then check its parent. And then you do the same thing for this. You operate on its children and then you check its parent. So there's sort of that repeated problem.
But for a BFS, like how do we avoid repeated problems in a BFS? Like typically in a BFS, you only visit every node once, right? So how do we avoid like having a bunch of sub problems? Like yeah,
you could have like a visited set where you're like, or you could have a visited set where you're, once you like are done iterating through a certain subtree, you mark its head as visited, and then you just like keep doing that so that once, let's say you process the subtree here, like the subtree that starts at 5, then you jump up to 2, and then you mark this 5 as visited so it doesn't bother with the 5 anymore. And then it does a subtree that starts at 2. And when you're done with that, then it jumps up to 1. And then you would, I guess you would have to keep track of the heights of the different subtrees to, at the end, be able to do like a summation of the subtree heights. And that would give you like the amount of time it would take for the entire tree to get infected.
okay. Well, normally in a BFS, like, so yeah, normally in a BFS, do you need to keep track of the heights? Because like normally BFS tells you like shortest path or longest path or whatever, and you don't really need to keep track of heights anything. You just need to keep track of like how far is this from my start, right?
Yeah. Though I guess that thing I described is not like strictly a BFS, because what I'm doing is I'm iterating through a child and then I'm going to the head and then iterating through its subtree. So it's like almost like doing 2 different steps. But I think, yeah, in a BFS it would be better to, I could do like in, let's say like you use a queue for the BFS. In the queue, I could add both children plus the parent, and then mark this node as visited, and then continue the BFS repeating that. So at the 2, I would mark its child. I would add its child to the queue and its parent to the queue at the same time, and then continue doing that, and then just like keep track of the number of steps that it took.
Exactly.
Total.
Yeah. So with that approach, what would be the time and space complexity?
So time complexity, first you would iterate down to the point where the infection starts. So that would be like O of n, because you would potentially look at every node. And then to do the BFS, you would also be looking at every node. So that's also O of n. So I think time would be O of n.
Mm-hmm.
And then space would also be O of n, because you're creating a hash map where you're storing every single element and its parent. So I think both are O of n, where n is the number of nodes.
Yep, I agree. Okay. Yeah, I think this looks good to me. Do you want to start coding it?
Yeah, sure. So the first step is to iterate through the entire tree and save all of the heads for every node. So you would have like a node to head dictionary.
Okay.
And then you would iterate through, starting from the head, iterate through all the nodes. So you could have like a iterator. I guess you could do this with a queue as well.
That's fine. I think this is the wrong queue. I think it's this one.
Oh, okay. Thanks. But this wouldn't be keeping track of the parent though. So let's say you start here, you pass in the head, then you would want to pass it, look at its children. And then sort of save the, I guess in the queue you could you use a pair where you pass in the node and its parent as well. So you could do something like maybe so here you're storing both. Or actually just use the dictionary.
Okay, so we have about 20 minutes left. We can continue with this problem or move on to the next. That's up to you.
Let's do the next one.
Okay. Okay, so the next one is you are trying to rob a bank, and there are rules for this. So you're given two things. You're given a security array, like examples like this, and you're given a time number. And so basically, for a given, like imagine these are different days and the time is an in number of days. So like this is day 0, day 1, day 2, day 3, whatever. This is how many security people, so I can write this down. So for security at index I, this is how many security is present at day I. So the bank is only robbable at day I if there are at least time days before and after I, where, and these are the requirements, so before days have to be decreasing or equal. So I guess another way to write it is non-increasing. And after days have to be non-decreasing. So to give you an example, let's say we take index 2. So for index 2, its value is 3. So there are 2 days where the values are non-increasing because it goes 5, 3, 3, so it's never increasing. So there's 2 days here that it's non-increasing. And there's 2 days after that it's non-decreasing. So because we have a 3 and then it goes to 3 and 5. So that means that index 2 would be a valuable time. And also index 3 would be a viable time because the 2 days before are like this difference is non-increasing and this difference is non-increasing. So there's 2 days there. And after, there's also 2 days where it's non-decreasing. This is increasing and this is increasing. So 3 would be another answer. So this would be the answer here.
I see. Okay, so
So basically, you just look at like the differences between the days, and there has to be at least that many days for every valid day.
I see. So let's say you want to rob so we're supposed to return the number of, an array of the days that we can rob at.
Mm-hmm.
And then, okay, let's see, 0. So this day is valid because
Yeah, and I can give you a little bit more detailed thing here, if that helps you. This is honestly might be more confusing, so. But yeah, basically it's like you just look at the difference between like days that are next to each other, and there has to be at least that many differences in a row that that you need.
I see. So over here, like 3 and 3, this is, it says days before have to be non-increasing. So is this not increasing?
So it's like the difference. It's the difference, not the actual day. So like if I rob here, this is the difference, which is 0, and this is the difference, which is -2. So you have -2 and 0. So maybe it's a little bit confusing. Does that make sense?
Okay, got it. Yeah.
Difference.
I And then here, when you go this way, you would do 3 minus 3 is 0, and then 3 minus 5 is -2.
3, it's no, you just look like where it goes. So it goes from 3 to 5, so it's 2. It's like the first one to the second one. So like here is -2 and 0,
Okay,
and then it's like 0 and 2. So that means there's two days in a row where you basically look at the change. Yeah, the change is non decreasing. It's equal,
Yeah,
not
like
decreasing.
okay, got it.
Yeah.
Yeah, because from here to here it's going down, so it's non-increasing, and from here to here it's going up, so it's non-decreasing. Okay.
Mm-hmm.
So for this type of problem, I kind of think that a prefix sum might be useful because you're you want to check the difference between like, different indices.
Okay.
So maybe you could a prefix sum for this, I guess, sort of this. This would be 5, then 8, then 11, then 14, then etc. So 5 into. The thing with the prefix sum is it's always going to be increasing. So I don't know if it'll have too much. It'll give us too much help in telling if something is going up or down at a specific point. Like it could help, but it doesn't seem like the most obvious aid for this problem.
Yeah, I agree. If you just maintain like a cumulative total, that will always be equal or increasing. So it doesn't really help.
Yeah.
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 So I guess let's start off with like what would be the brute force for this problem?
The brute force would be you go to every single point and then you iterate outwards from each index and just check whether the conditions are met.
Right. And what would be the time complexity?
That would be n squared because you're checking every single index and then expanding outwards to check every index potentially.
Right. And we're basically looking for like this how many days in a row type of thing. So I do agree a prefix sum of totals doesn't work, but is there a prefix sum of anything else that we can do that would be, or maybe not even a prefix sum, but just like store something else that would be good and that we can store without doing this n squared thing?
I guess you could have the differences, like the differences different. Let me try creating an array of differences. So this is 2, this is 0, this is 0, and this is 2, and this is 1, and no, wait, this is -1, and this is -2, and this is 4. So I guess what we see here is that's useful is that these two are greater than or equal to 0, and these two are less than or equal to 0. So because we found that we have like time equals 2 elements greater than equal to 0 followed by 2 elements less than or equal to 0, we know that there's a valid index like in between them. So this sort of reminds me of those like mountain those problems where you have like a bunch of like increasing numbers and then a bunch of decreasing numbers, and you kind of want to find the point where like it starts switching from increasing to decreasing. So here it would be like the opposite. You want to find a point where it's like going from a number to 0, and then it starts going from 0 to a negative number. So finding that like midpoint between those slopes would be helpful, I think.
So I don't know if you're on the right track, and also even if that's the case, we'd have to find these things, and like there can be a lot, so we wouldn't be able to get them very quickly. And then we'd also, even if we go through in linear time and look for them, we have to know like basically if we're here, we have to know like how big is like the drop and how big is the the increase, right? So I do agree, like if we knew how
Yeah.
long this was and how long this was, then we have like our answer of like, is this a valid thing? So that's the thing we really care about, is like how long this is and how long this is. So basically you storing differences doesn't really help, because you still have to like look at all those differences for every single point.
Mm-hmm.
So instead of seeing like how, like what are the differences, what if we maintain like a length of the like the increase or the decrease? Does that make sense? So like we could say, you know, like we have like one increasing value in a row, 2, 3, whatever, and then when we're at a
Yeah.
point, we're like, oh, there's 3 here and 3 here, so we're good, and so on.
Okay, yeah. So maybe like some sort of two-pointer approach where you start here, and while it's decreasing, you move this to the side, and you have like a variable that's like counting like num decreasing or something like that. And then you keep track of that.
Okay.
And then I guess the issue is these are all equal, so you like keep increasing num decreasing the num decreasing variable when you should at some point realize that we've switched to an increasing. I guess you could keep track of num decreasing, num equal, and num increasing, and then you would have like a bunch of decreasing ones, and then you would have a bunch of like equal differences between numbers, and then you'd have a bunch of increasing differences between numbers,
Okay.
or like
So
opposite
basically,
order.
so what we need to know is for every number, like what's the, not the num, but we need like the length of, or num, whatever, num, uh, non-increasing, which is equal or decreasing
Yeah,
on the left side, right? Plus
yeah,
num equal or increasing on the right side. And if we have this for a given index, then we could say like, well, does that match our time requirements? So I don't know if this can be done with a 2-pointer, because there's just not like, you can't store that much information. But what if we just had like arrays with this information? So we can have one array that's like the left like total, and then one array that's like a right total, and then we can just like look those up as we go. Does that make sense?
I see. So let's say let's create the array for num equal or decreasing left. So for that, here at the very start, I guess it would be 0 numbers are to the left of this that are equal or decreasing. Over here, you have 1. That's okay. Here you have another one that's okay. And then here you have another one that's okay. And then etc. And then on the opposite side, here, let's just do the first 4. So over here you have 1, 2 that are okay, because the 5 and 6 are both bigger than the 3. And then here you have 3 values that are okay, because you have 3 values that are greater than or equal to. Here you have 4. And then here you have 0. Or
Yeah, you need it to be in a row. So yeah.
Yeah, so here you have 0.
Okay.
And then if you look for pairs where the minimum of the pair is at least time.
Mm-hmm.
So okay, I did this. Wait, let's see. This one has 1. This one is okay because it has 2, and this one is also okay. So you would end up with these 2 pairs that are okay. Okay, so that makes sense. Yeah.
Okay, and then
And that
what's
would
the time
be,
and space for this?
yeah. So it's O of n because you're just going back and forth like a few times, and then space is also O of n because you're also just creating like 2 extra arrays of n size.
Mm-hmm. Okay. Do you want to code this then? Does that make sense?
Yeah, that makes sense.
Okay.
So let's first do the one where you check to the left. So I guess for this one, you would kind of want to skip the first slot. So let's do like let's call it like num to left greater, or let's say greater or equal. And then it starts at 0, and you kind of you want to look at these numbers here and compare them to starting points. So let's say like or equals nums I minus 1, and then next so if next num is, let's actually call this previous and call this cur. I think that's cleaner. So if previous is greater than or equal to cur, that means that that this you increase this by 1, and otherwise you kind of just set it to 0 again because the consecutive streak has been broken. And then you kind of want to do the same thing again, but for the other array. So this one you want to iterate backwards. And I think again you want to skip the first you want to skip the first item in the array because there's nothing to the right of it. So you could do And then you just want to iterate through both of these arrays. Let's keep like a result array here. I think something like this is what I was thinking of.
Okay, yeah, I think this makes sense. I think you just have, let's see. Oh, you have some errors, so can you fix those?
Oh,
Use his voice stuff.
Yeah. Here.
Okay.
Okay.
Okay, so I think we're right at time, so we can do feedback now. So how do you think you did? What do you think you did well? What do you think you can improve in?
Okay, so for the first problem, like, I think I just froze, honestly, because usually when I'm practicing on LeetCode, I'm able to like iterate through a tree like automatically, but I always do it recursively, and for some reason I decided to iterate through it with a queue, and I just like forgot how to do the write it out, and I just like froze. And also it took me forever to come up with the solution because I kept trying to split into two problems where you iterate from like the top head, and you also iterate from the virus print at the same time or something like that. So I kind of like didn't do good in the first problem. And then for the second one, I think because it's like, it kind of reminded me of like a palindrome sort of problem. So I was sort of thinking about a solution that would relate to that, but I guess this sort of solution with two arrays is much simpler. And also just mentally, I was not like visualizing what it would mean to have like non-increasing on one side and non-decreasing on the other. Like, it's more simple than what I was initially thinking, but
yeah, I think maybe I could have done a better job explaining the problem, and also maybe make it a little bit easier where I could just have a requirement where all the numbers next to each other are never equal, and then it would be like a little bit easier to understand. But yeah, I think
I think I got confused for no reason really, because when you think about it, it's obvious. Like, you just need to make sure like the numbers to the left are bigger and the numbers to the right are also bigger. But yeah, that's kind of
yeah.
what it was
So
like.
I think so for the first problem, there's two approaches that work, and there's a common pitfall that people go down, which is yours, which is people are like, I'm gonna break this problem down into like going from the root to my infected thing, and then like other paths. And then I have to point out that like, well, depending on where the infected thing is, there might be a ton of other paths, and it's hard to know for sure like what's where. So the better way to think about it was there's basically like two solutions. One is the hash map parent, and another one is turn it into a graph. I personally think turning it into a graph is easier, because then you just like, if you have a graph with a what's called undirected edges, then you just do BFS from the node, and then like your longest path is like the answer. But the parent also works as well. And so I think the problem you had was you tried to do the multiple paths, and you tried to make a stack with some stuff. And then I basically had to hint to you like, hey, you're doing something too complicated. Like, the fundamental problem is we can't go up to the parent, so how can we solve that? And then after that, you were able to like figure out roughly what to do. But yeah, there is like the time thing too, where like if you have to do both of these problems in 40 minutes, then like, and you take 30 for the first one, then it's going to be kind of hard. So you definitely want to avoid, this is pretty common what I've seen as well, people try to kind of bucket a problem into some other problem. and then that makes them go down the wrong path where like you think it's something like this and it's not, and you just completely have the wrong solution. So I would take every problem by itself and think about it like what makes sense, what's the problem you're trying to solve, what are the algorithms, not just like what bucket does this fall into, because that can be very dangerous. Does that make sense?
Yeah.
Okay. So yeah, basically, if you understood that you need a parent or you need a graph, I think it's a pretty straightforward problem. I think that's the hard part of this problem, is understanding that, like, oh, I need to just be able to go in every direction, and then it's just a BFS. So because you didn't have like a working solution, we had to move on. This would be like a no hire, lean no hire for the first one. And then for the second one, I never asked him before. I do agree I could have asked it a little bit better, but I also clarified, like, when you were saying the wrong thing, I was like, this is exactly what it needs to mean. And then you were trying to do a prefix sum, which, yeah, basically you realize like, oh, hey, if I keep having a cumulative total, it doesn't really work. So the main thing you need to recognize is like, okay, for every day, I just need to maintain of like the streak of days that are increasing and decreasing. And I can maintain like, I mean, a really simple problem is like, what's the streak of days to the left of a number, and you can just like do that in a one pass. You can just calculate as you go. You basically keeps increasing or resets to 0. And then the same thing the other way, it keeps increasing or resets to 0. And you could say that there are other examples of this where like you need to have some kind of calculated thing, and you need to do this. But yeah, like I think for the second one, I needed to give you. I mean, I basically wrote out the solution as far as I think. Like, so this would also be, like there's way too many hints, and I was like, we're running out of time. I want you to have something, so I'm going to explain it in like very good detail. In a realistic interview, people will probably just keep hinting you until you don't get it, and then just have like a fail, because you need to get it eventually. So with enough hints, I think I even said like, so the prefix sum of what you're doing doesn't work, but can we store something else that would be useful? So then we can calculate this in O1. So the main thing to recognize is like, okay, so the brute force looks like I need to expand out from every node, and if that doesn't work, then like what else do I need? So obviously I need to have something pre-computed for these nodes. How can I have something pre-computed? Well, I can just go left to right and right to left and then figure that out. And then your coding was also had some bugs. So for example, here, like you access a new index every time, but you're doing +1, so it wouldn't be +1. It would be like the one before +1. Yeah, same thing the other way. Let's see if there's anything else. Oh yeah, so the other thing is this. So it needs to be decreasing going down. So this needs to be like this way. And then this basically needs to be num to right like less than or equal or something. So you basically had like the wrong thing there, but I'd say those are like small things. Like I think you understood kind of how the algorithm's supposed to work, and those are like small things, so that part's not too bad. I think the main thing is get problems and then be able to problem solve quicker and have a correct solution quicker and understand what you're trying to do quicker. So, if you do these problems and it takes you like 15 to 20 minutes to come up with like a solution, that 15 to 20 minutes needs to come down to like 10 to 5. And then you can worry about the coding. So I don't know, like how much LeetCode have you done already?
I've done like 250 problems, but a lot of them I did with a bad process where I was like running like bad solutions and stuff just to see what would happen.
Oh yeah, that's the other difference for not running your code and LeetCode is LeetCode you can just write whatever you want, run it, and then debug from there. With this not running your code thing, like you need to know up here that what you're doing works, and you need to have pretty high certainty in that. So that's like a very different skill set. So you can practice like that exact format of like maybe you do LeetCode and then you're like I can't just keep running it and then like debug after I run it. I need to come up with like a solid strategy, and then I need to be confident that strategy works. And then the next part is transform that into code. So I would, if you're practicing for interviews where they don't let you run your code, which is like most things, I guess, I would practice like that format of like, make sure your plan is pretty in detail and you have it like very well understood. And then your coding is basically like, I know exactly what I need to do, and now I just need to write the code for it. Instead of, what you said is super common. People are just like, I think the biggest red flag is like when people start doing a problem, they read the problem, they're like, all right, and I'm gonna start coding. and they have literally no idea of like what's going to happen. So I would definitely get away from that and like plan out your approach more. It might take you longer at first, but it's going to like pay off more like long term. And you need to have a very good understanding of what your algorithm is because you're not allowed to run it. And then obviously like, it's okay if you make an algorithm and then as you start coding, you're like, oh, actually this is going to change or this is going to change. But ideally, when you hit submit, it should work more often than not. You shouldn't just be able to use test cases to completely change your code.
But do you also recommend like not even looking at the examples and trying to make your own or something? Because a lot of times when you like just stare at the examples with a pen and paper and like write it out, it makes it like so much easier than what we're doing in an interview.
So this depends. Like I try to make things vague. So like if a problem has 3 examples, I'll just give you 1. And then I want you to come up with the with a pattern. Because I do agree. Like the security thing had 3 examples. And maybe with 3 examples, that approach would have been like a lot easier for you. So I do agree, yeah. Maybe look at like example 1. And then if you understand what the problem is saying, write out some more yourself. And then I think that's a really good strategy of like, let's say you don't know what this problem's asking. So I give you the first example and you're like, I don't know if I know exactly what you mean. So I'm going to write out another example and I'm going to tell you what I think the result should be. And you can let me know, does this make sense? Because then that goes to show that like you understand exactly what the problem is asking. Does that make sense? So you can do that in LeetCode as well. Like maybe read the first one and then come up with some more yourself. I think that's definitely a good strategy. Yeah.
Okay.
Yeah, so definitely focus a lot more on the making your own examples and planning out an approach instead of just, brute force coding and like changing your code whenever you get a not accepted. Yeah.
Yeah.
And then some companies will let you, so there's like two variations. Some companies will let you run your code. If they let you run your code, they might only give you 1 example and then you have to come up with examples that like test your edge cases. And people struggle with that too. Like they just write a bunch of examples that test the same thing. So when you come up with examples, try to come up with examples that actually test edge cases, and then get in the habit of like coming up with good ones there. So for example, for this infected thing, maybe like the root can be infected, maybe like a leaf can be infected, maybe something in the middle, stuff like that. And then with a security thing, maybe you can try like a completely increasing array, an array of all numbers that are all over the place, a completely decreasing array, an array that's like all the same, stuff like that.
Yeah.
And I think, so for what it's worth, so I don't know if you've seen like LeetCode ELO ratings or something. So these were basically both around 1700, which I would say is like the average problem you get asked for like a faang, I guess. It's like an average medium.
I think this like really emphasizes the difference between an interview because I feel like I've probably done like some problem like this on LeetCode, but it's when you're just like staring at the example with a pen and paper and you can write everything out and then you retry multiple times, it's like obviously going to be much easier than doing it on the spot in an interview.
Yes. And also I purposely try very hard to pick questions that aren't on like a NeetCode 150 map or something. Because when I find those, people are just like, oh yeah, it's that. I've done it a lot. Here's the answer. Okay, bye. So I try to pick something that's very unique and non-obvious, and it tests your like problem solving instead of like, what's the pattern I did in a NeetCode 150 for this?
Yeah.
So, and that depends on company. Like a lot of startups will just pick stuff from that. And then what ends up happening probably in their interviews is people solve the thing in like 10 minutes and it's like, okay, well, what did that show you? Nothing. So have fun. But yeah, so do you kind of have like the takeaways you need?
Yeah.
Okay. And then if you have any other questions or anything, you can feel free to like ask in the Discord or whatever. I'm happy to answer anything. And yeah, I'll upload this like in tomorrow or the next day or something, so you can like watch the video and like my notes and all that stuff.
Sure. Okay.
Okay, cool. Catch you later.
Yeah, thanks.